very important questions, and we are going to tackle a very cool problem, that is 3372 3372 problem number from the Leetcode. And this question is you can say very important to understand the graph as well as the tree concept is here. And let's understand the BFS approach in this problem. So problem is saying that we have maximize the number of target nodes after connecting trees one, right? So this problem is targeted as hard, right? But don't worry, we will break it down step by step to understand the intuition, and we'll optimize it, and we'll write the very clean Java code that we have seen, that you can see here in the right side. Okay, so let me bring my you can say complete view for this problem, right? Let me zoom little bit. Okay, yeah, so as you can see, right, we have complete problem statement is here. You just pause this and go through, so you will have the clear understanding for this problem, right? So let me read for you, and then we'll understand what the problem is saying. That so the problem is saying that there exist two undirected trees with n nodes, right, and m nodes. So there is two undirected trees with n and m nodes with distinct levels in range 0 to n minus 1 and 0 to m minus 1 respectively. You are given a 2D integer arrays as is 1 and as is 2 of length n minus 1 m minus 1, right, respectively, where the edges at I is a and b, indicates that there is an edge between node a and b in the first tree, and edges at 2 I, we have u and v, that indicates there is an edge between node u and v in the second tree. You are also given an integer k, right, and node u is target to node v if the number of edges on the path from u to v is less than equal to k. Okay, means it is saying node u is a target. Node u is a target to node v. Node u is a target to node v if the number of edges on the path from u to v, number of edges on the path from u to v is less than target k. Understand? Means the given node u is a target to node v. Okay, and only if the number of edges on the path from u to v should be or is less than equal to k. Okay, now it is saying that note that a node is always a target to itself, right? This is a note, right? Now understand, return an array of an integer's answer, right? We have to return an array of integer, that is called answer, where answer at I means each element is the maximum possible number of nodes target to node I, means number of I is the maximum possible number of nodes target to node I for the first tree if you have to connect one node from the first tree to another node in the second tree. Okay, and you have given the queries that is independent from each other. This is for every query you will remove the added edge before proceeding to the next query. I hope you understand, right? So what you have to return? You have to return the answer, where answer at I is the maximum possible number of number of nodes target to node I for the first tree if you have to connect to one node from the first to another node in the second tree, right? Means we'll understand with this example clearly, right? So the question having one example one, and example one having is this S1 and another we has S2, right? So if you represent this edges in a graph, you will see that this is the tree 1, right? And tree 1 having 0 1 0 2 3 and 4. So this is the first tree, and another tree we have is this, where we have couple of nodes are there here, right? So if you observe this, with this help of these edges we have these two nodes, you can say trees, you have, and trees 1 and tree 2 we have represented in the graph, right? And we have also given k is equal to 2, right? So how we are going to connect it, that we are going to understand. And the output, that is what the output is the array of answer. This is answer, where each these elements, as you can see, like 9, 8, 7, 5, like these are the elements, right? So these are the element is the maximum possible number of nodes target to I of the first tree if you have to connect to the node of another tree. Let's suppose what I'm trying to say, that how many nodes are there here? You just think there is 0, 1, 2, 3, 4, right? Means total 5 nodes are there. Means how many answers should be there? Total 5 answers should be there. You count it, this will be 5 outputs should be there, right? And these outputs are the maximum possible number of nodes target to node I of the first tree. Means I'm talking about, let's suppose, node 0. If I'm talking about node 0, right, from node 0 to, you can say, if there is an edge, we have to find, right, how many nodes are there, right? That we are going to count, and we have to put here, right? Number of maximum number of possible nodes we have to find, right? And for that, I think you understood. So let's understand for node, for I equal to 0. I equal to 0 means we are talking about node 0. So connect node 0 from the first tree to the node 0 from the second tree. If we will connect 0 to this node 0, right, what will happen, right? That you have to connect. Similarly, you will connect I equal to 1, right? Means connect node 1 from the first node to the node 0 from the second node, right? Second tree. Means this first node we have to connect with this node 0. Similarly, for 2 and 3, you will connect, right? For connect node 2 from the first tree to the node 4, connect 3 from the node 4, and this, right? Like this we have. So if you pause this, and if you see this, these are the connections we have given, and we can make the you can say, we can connect them, and we can make a connection between them. We can make the path between them, right? You go through this example, you will understand, right? So let me teach you how this example works, right? So okay, second, which you wait. Okay, so what we have given, so in the S1 we have given, right, the first example we have given what, like this. So this is the tree 1 that we are going to represent, right? So if you will represent this, you can represent what, 0, 1, 0, 2, 2, 3, and 3, 4, right? You can represent. Similarly, you can represent this another tree like this also, right? You can represent this, correct? Means we have 0 is connected with what, 1, 2, and 3. And similarly, you can say 0 is connected with what, 0, 1, 2, and 3. 3 is not connected with anyone, so you can leave it like this, right? So either you represent like this or this, it means it is like this only, right? Okay, just think that these trees can be represented like this, right? You can, if you represent this tree 1 and tree, so I'll call it as a tree 1, and I will call it as tree 2, as we are given here tree 1 and tree 2 we have given, right? So what is our goal? So for each node that we have given in this example, right, for each node in tree 1, let's suppose I'm talking about this node. These are the nodes we have given, right? 0, 1, 2, 3, 4. These are the nodes, right? So for each node, we can say this is I, right? I start from 0, 1, 2, 3, 4, right? So for each node in tree 1, right, we will connect it to the some nodes in J, right? Any of these nodes. So these nodes we call it I, right? And these node we call it as J, right? So we can say that what is our goal? Our goal is for each node I in the tree 1, we will connect it to some node in J in tree 2. Then if we are going to do for each connection for this node to this node, right? From here, this node 1 in the tree 1 to tree 2, right? Means how many total nodes are in the target node I. Means if we want to compute how many nodes, you can say, yeah, you can say how many total nodes are in the target nodes to I, right? Target nodes to I means, is it reachable, right? If it is reachable, so you can check with k, so it should be less than equal to k, right? The reachable in less than equal to k. So these are the two conditions. Means for each node in I, in the each node I in the tree 1, right, it should connect it to some nodes in J, right? Then we have to compute, right, how many total nodes uh, are target nodes to I, right? Like that we can say, right? Okay. So node, let's suppose for node 0, right? Node 0 in the tree 1, if we'll do BFS in the tree 1 from 0 node, and k should be less than equal to 2, right? How many levels are there? Level is 0, 1, 2. So in level 0, we have only one node. In level 2, we have two node, 1, 2. And level 3, we have two node also, 3, 4, right? So each level have some nodes, right? So you can say if you'll do BFS, breadth first search, right, in tree 1 from node 0, right? So we will go with the level by level 1, right? So for breadth first, this is 0, 1, 2, right? So from 0 within k is less than 2, we can say that, right? Because k is less than equal to 2, and the number levels is, how many levels are there? 3 levels, 0, 1, 2, right? And that is satisfied, right? So we can say it is satisfied. So total reachable nodes will be 0, 1, 2, 3, 4, right? Sorry, 0, you can say 1, 2, 3, 4, 5. Total we can say 5 nodes because it starts from 0, right? So the best connection in tree 2 is what? Means we have to connect to node 2, tree 2 nodes 0, right? Or any of 0, 1, 4, right? 0, 1 and 4, because this is level 1, level 2, you can say level 0, level 1, level 2. So either of these three we can connect in tree 2. So any 0, 1, 4 we can connect, right? Because the level we have given in the tree 1 is 0, 1 and 2, and it should be less than equal to 2. So k is 2. If k is 2, means this we can reach, right? It is reachable nodes, right? But in this tree 2, the best connection are 0, 1 and 4, right? We can do that, right? So within k minus 1 equal to what? K is 2. 2 minus 1 is 1, right? So from node 0, right? From node 0, we can come what? 0, 1, 2, 3. 0, 1, 2, 3. If we'll talk about from 0, we can go to 1, 2 and 3, right? So within k minus 1, from node 0, we can come to node 0 itself, we can come, then 1, 2, 3. Means if I'll connect from 0, I can connect to 0, 1, 2 and 3, right? So these are 4 nodes. So total already it was 5 node. Here it was 4 node, right? 4 nodes we can connect, right? 0, 1, 2, 3. Means 4 node here, 5 node is here, right? So total from tree 1 is how many? 5. And total from tree 2 is what? How many? You can connect these 4, right? So total is 9. So answer it is coming here is 9. I hope you understand, right? Similarly, from the node 1, right, if we'll do the BFS from this node 1, So how many levels are there? We already level 1, but 0, 1 and 2. These are the levels we have given. So so if we'll talk about this node, right, from node 1, level 0 is, let's suppose 1, right? Level 1 will say 0, and level 2 is how many? 2. So if we'll consider this node as a level 1, level 0, so let's suppose this will go up here, right? We can mark it as up here before the 0. So this is level 0. So this will become what? What I'm trying to say, let me rewrite here. So we are removing from here. Let's suppose we are removing this here, and we will make what? Like this, and this will say 1, right? Now tell, if this is 0, if this is 0, this is 1, and this is 2. So 3 levels is already there. Can we say that? We can say that, right? From node, we can say, right, this is level 0, this is level 1, this is level 2. So if you will, how many reachable? Because k is equal to 2. K is equal to 2. So these are 3 nodes, right? You can say 3 nodes is here. It is reachable, right? In this node first. Let's talk about the node 4. These nodes we'll talk, right? Now the best 4 nodes are these 4, right? 0, 1, 2, 4, 3, right? 0, 1, 2, 3, 4, right? So that there is 3 here and there is 4 nodes here, right? So how many nodes are there total? 3 plus 4 is 7, and so you can see this is 7. Similarly, if we'll talk about in the node 2, right, if we'll start from here, so these 2 are done, right? Now understand about the 2. If it is 2, it is on the 0, right? Just think about, this is on the level 0. How you consider that this is on level 0? You 0 and 1 can we go down, right? If you represent this like so what you can do, this is 2, right? So one more down we can make like this from here, like this, and we'll say this is 0, and then we can say this is 1, and we will remove this. Can we do that? Just think, can we do that? So level 0 is 2, level 1 is 0, 3 and 4, or you can say 3, 4, 0. You can put here also, right? Before 3 we can put 0, and after that we can put 1. So it will become like 0, 0, 3, 4, right? So we can make it, right? So how many node is here in this case? Sorry, and level 3 level 2 is 1. So level 0, level 1, level 2, all these nodes are, how many nodes are there? 5 nodes are there, right? 5. And here it was, these are 4. Understood, right? So there was 5, there is 4. If we'll do add, right, how many is coming? 9. I can see it is coming 9. 9 nodes are coming. Similarly, if we'll talk about node 3, let's talk about node 3. This node, just similarly, if you'll make it up from the 2, how I'm talking, let me write like this. These are the possibilities that you can make it, right? Okay, just think that there is one more node is there, and that is called 3. So this node is level 0. This node is at level 0. Now level 1 have 2 and level 2 have 0 and 4. We are discarding this time 1. How many nodes are there? 4 nodes are here and 4 nodes are here. Total is 8, and so it is coming 8. Similarly, you can do for 4. This time 4 will go up, right? And so it will come again 8. I hope you understand, guys, right? And that is why this is the output is coming. I hope you how are going to connect it, right? So why we are subtracting 1 from k when looking at tree 2, right? Why we are doing that? If you observe that here we are taking what? 0 and 1. We are not going to the next level, right? That you can think, right? Because you will say sir is going with all these 3, right? It is going for all these 3 levels 0, 1 and 2. But here sir is going with only one level, only 2 level. He is discarding the level 1, means k minus 1 he is doing. Why he is doing k minus 1? Why he is subtracting with the k, 1 from the k, right? If you will look here, you will understand clearly. What? Because when we connect a node from tree 1 to tree 2, we use one edge, right? We use from here to here. If we'll connect it, we are using one edge, and so we have now k minus 1. If we will take from here, right, and we will go connect to here, means we are reducing one edge, right? Because these edges are given, right? These edges are already given. Okay, so if we will connect, right, from any node from this tree, right, to the node of tree 2, right, means we are using one edge, and so the edges are already given, right? So we can say we can take k minus 1 edges left to explore in tree 2. I hope you like this video, guys. Let's understand the coding part, right? So first of all, what we need to do, we have given these edges we have given and k we have given, right? So our intuition was like for each I in the node in the tree 1, right? So we will build the tree from here, right? So tree 1 and tree 2 we are building, right? So first step we will build the tree 1 and tree 2 using this you can say edges, right? So we'll use these edges and we'll create this tree, right? So our intuition was for each node in tree 1, right, we want to connect it to any node in the tree 2, and to find out the maximum number of target nodes that is reachable should be less than equal to k, right? So for each connection between tree 1 and tree 2, it takes one step. So we left with k minus 1 steps for tree 2 traversal, right? So we will use the answer. I'll show you. So this is the count, and yeah, we'll use this answer, right? So result at I will be our answer. Okay, means the nodes that is reachable in tree 1 from I with k steps, that is this, right? So this is the all the nodes that is reachable in tree 1 within k steps from I, right? So for you can say from all the I, right, you will get this reachable, right, and you will have this reachable nodes information, right? Then there will be a max tree 2, so maximum reachable nodes in tree 2 from any nodes with k minus 1 step, right? That we will find. All these will do sum and will return it as a answer at I, right? So this is our answer at I, right, and we'll return it in example, right? So there will be we will do a BFS and we'll pass the tree 1, and for all I we'll go and we'll keep checking the reachables from tree 1, right? And we'll keep updating all the results at I, right? So you will get a list of elements, or you can say array of elements, right? So what are the steps we will follow here that we are going to see? So let's understand first that we have given these edges we have given. From there we will build the tree 1 and tree 2 using the adjacent list. Then in step 2 we'll compute max reachable nodes from tree 2. So k-1 step will take, you can take a variable like this. So you can find the max you can say max reachable nodes in tree 2 from any node in the k-1 step. So you will take k-1 step because you have already used one edge, and so we will pass k-1 edges, right? And you will use the BFS algo, so you will find all the reachables. And once you have the reachables, right, you can find the max one. So you can take another variables that we have already taken max one. So this is your reachable. If reachable will have optimize, or you can say increase, the count has been increased, so we are just updating this one, right? So will become the top one, like top count will become, right, a max count it will become. Okay, similarly we will use step 3 for each node in T1 and will compute reachable nodes from the k steps. So we'll pass all the k steps for node 1 for tree 1, and we'll find the reachables, and we'll keep adding the reachables with max tree reach 2, right? And we'll update our answer. Okay, and we'll return the answer. Now we'll build the you can say graph, right, or you can say tree, and we'll return it using the build graph. So this is the build graph internal method. I know you will aware of. So you will create a graph, you will go for all the nodes and you update its graph at I, and you will keep updating all the adjacency through the traversing all the edges, and you will return the graph. After that you will perform a BFS. You know the BFS, the start node, and the this will the max distance, right, will take. So this will be your visited nodes array. So once the array is visited, you will mark as a visited. So first we'll start from the start node and we'll mark it as visited. We'll take a queue and we'll add a start on the queue. You check the queue. If it is not empty, take the current node, you get the node and its distance, and check if it is distance is greater than max dist, continue, otherwise count plus plus. You traverse all the nodes of its current node and check the visited is marked, the neighbors is marked visited or not. If it is not visited, mark it as visited, and you process this node, and to process this you have to add into the queue, and finally you will return the count. I hope you understand, guys, right? And so what are the steps I have done here? Let's understand. Okay, so first of all, in the step 1 we will build the tree 1 and tree 2 graph using the urgency. Then we will compute the max you can say pre-compute the max number of nodes reachable from any node in tree 2 using the k-1 steps. And then we will use node 1, right? For each node in tree 1 will compute the reachable nodes in k step -1, right, in the k steps, right? And these are the helper methods where we will build the, you can say, graph, and this is the BFS method that we will build the BFS, right, function, or you can say method. I hope you understand, guys, right? So in the summary we can say that we will build the graph using this build method, right? This is the helper method, right? So this method we will use to build the graph using adjacency list for tree 1 and tree 2, and this will be your BFS method, right? So this BFS method will traverse for all the nodes, means for any given nodes we will return the count of nodes that is reachable within a given depth using the BFS, and there will be a max reachable, right? So the max reachable in tree 2 will find, right, and we'll try every nodes in tree 2 and we'll find the number will find the one that gives you the max reachable nodes in the k-1 steps, right? And that we will return, and we'll update our answer, right? We'll find the sum of both reachables nodes in both tree and we'll update the answer, right? So this is very efficient code, right? So if we'll talk about the BFS, right? So BFS will take because we are traversing for all the nodes, right? We are traversing for all the nodes in neighbor nodes, so we can take it will take O of n times, or you can say O of m, right? So we do BFS for each nodes in tree 1 and tree 2, and so the total time will become O of n square plus O of m square. So if tree 1 have O of n square, then tree 2 have O of m square, so we'll both do plus, and in the worst case it may become more than 1000, because the it was given, right, the constant was given should be less than equal to 1000, right? So in the worst case, this will be possible that O of n square plus O of m square will be the worst, but I don't think this will be worst in these given inputs. But let me know in the comment section that you understand the code, and please hit subscribe this channel so we'll get more videos like this, and let me know if you have any suggestions for these videos. Thank you guys, thank you for watching this video, and I hope I'll see you in the next one.